I said if you got anywhere in the 30s and 40s last night, I was proud of you. Now what's weird about getting in the 30s and 40s last night? Right?
Yeah. For sure.
But, hold on, wait. My ones that did work on homework, you were discouraged, but still, the ones who were in here yesterday, you kept pressing through. Why were these first ones long? And technically, it's all the way up to about 63. Not all of these, maybe starting around here. Why were they long?
So many separate
You had to do the whole process of what? If it asked you for, find where the function analytically, algebraically, whatever, without a graph. It tells you to figure out where the function is increasing or decreasing. What do you have to do? Remind me of the steps. 1.
Derivative.
Find discontinuities. Domain problems, right? Number 2, find the
Critical numbers.
say critical numbers and then remind yourself forever because tomorrow, right? Critical numbers. Take the derivative, set it
Equal to 0.
or
Pitchfork.
pitchfork, top equal to 0, bottom equal to 0. Find the zeros or the undefines, right? When the bottom equals 0 of the first derivative. Okay, so we find the discontinuities, number 1. We find the critical numbers, number 2. Number 3, we put those numbers in a number line sign chart, right?
Yes.
Number line sign chart. If the domain is restricted, wasn't that the first one? Where everyone had a square root with 16 minus x squared. If the domain is restricted, we don't have it going forever, those will be imaginary. We stop it at like the negative 4 to 4. Hint, hint, homework problem. But if the domain is not restricted, what's going on? Forever number line. You put in your special numbers. What do you do with the sign chart? You plug in test points for each and every interval. Plug into who? Whose sign on top are we trying to find? The derivatives, f primes, right? We plug into f prime, we check if it's plus or minus at those points, and then we're able to say on bottom what f is doing, whether it's increasing or whether it's decreasing, and we have our answer done. What's extra for those problems that say find the relative extrema analytically, algebraically, without a graph? You take your sign chart, all the work, 1, 2, 3, and you say, okay, cool. Is there a max somewhere? Would you be able to tell by the first derivative changing from positive to negative or the function changing from increasing to decreasing? As long as the point exists. And you look at your little sign chart and you say, hey, is there a minimum? What would you see to see a minimum?
Increasing and increasing.
Who's changing from negative to positive? The derivative is changing from negative to positive. The function is changing from decreasing to increasing. Either of those say, hey, there's a min as long as the point exists. Okay, done. That's the majority of homework. Oh, that sounds not too bad, except number 1, there's 1, 2, 3 steps for one, 4 steps for the other. And guys, those of you that worked on homework, let everyone know, where was the struggle? Remembering the 3 steps or the 4 steps?
Yeah.
Doing what? What part was probably the, seriously, this is going to take a while. I don't think the intervals. Maybe the testing of the signs. But I think a lot of them were just taking the derivative and making it into a nice fraction to do the pitchfork with, right? I think that was probably the most frustrating for those because you were like, seriously, a square root function? I have to, quotient rule? Oh my goodness, right? But were there a couple with power rule? Yes. So hang in there. Well, let's come on back. For those of you guys that have yet to do homework, you need to power through 63 and then it gets faster, okay? And you're like, but okay, it looks horrendous, but the hard stuff up through here is not necessarily going to follow all the way through. Let's go ahead and do some of those examples so the concept-y ones that are supposed to go quicker actually can go quicker, okay? Bless you. Concept-y ones having to do with graphs. Yesterday we saw one type, and actually, I think this might be a homework problem. Or at least it was in a section of homework problems. Because I gave you quite a few in here. I gave you 77, maybe to 81. Okay. So I did one of them in the section. Now guys, hold on. Do you remember how I did this one yesterday? Whose graph do we have? F. So what was I able to fill into my sign chart? Stuff about the top or stuff about the bottom? Where did I start filling in? The bottom, because I have F. And what was F doing? He was increasing. Uh-oh, he went vertical. And then he was increasing again. What does that mean? Well, that means he was increasing, right? Vertical. Uh-oh, that means a vertical tangent line, which means F prime does not exist. at 0. Vertical tangent line, f prime does not exist, and more specifically, it's going to be a vertical asymptote to be super specific. And then the function increases some more. So then I was able to say, oh hey, f prime is going to be positive. I went backwards. F prime is going to be positive, and then at 0, f prime is going to be dne. What kind of dne? The marker just flew. What kind of dne? The kind of dne where I have a vertical asymptote. So when I'm graphing the derivative, put in a vertical asymptote. Positive means f prime is positive whenever he is above the axis, greater than 0. F prime is negative whenever he, the derivative, is below the axis. So then we said, okay, fine. He's increasing to a vertical asymptote, increasing to a vertical asymptote. He has to stay positive. He can't go below. Well, what's the only way he can keep on going then? If he can't go below, he must be getting closer and closer to 0. Closer and closer to 0. And does that make sense with this flattening and getting closer and closer to a horizontal, and this flattening and getting closer and closer to a slope of 0? Yes. But this is a hard idea, right? So we're going to work more on graphs. But another graph that you could have is the graph of who? Uh-oh. I don't have the graph of f anymore. I have the graph of f prime. So I'm going to look at this graph of f prime, and instead of filling in the bottom of the sign chart first, I'm going to fill in the top of the sign chart first because I have clues about who I have. Now remember, whenever f prime, his y values are above, he's positive. And whenever f prime's values, because this is f prime, whenever he's below, well, he's negative. Just like in the olden days in pre-cal, if y is positive, that means he's above the axis. If y is negative, he's below the axis. And since we're given f prime, he is our, in a sense, he's our original, or our starting place. So where was f prime above the axis? Well, negative infinity, right? He's above, all the way to negative 1. Negative infinity all the way to negative 1. What's another reason that I should stop at negative 1? What's f prime equal to? What is the y equal to at negative 1? 0. He's an x-intercept. So I can take the zeros of the derivative and put them in as my critical numbers. The zeros of the derivative are the critical numbers in my sign chart. Not the maximums and minimums. I'm not looking at f. I'm looking at f prime. His zeros go in my sign chart. Where he's above, he's positive, which means the original must have been increasing. Where he's below the axis, the f prime is negative, which means f is decreasing. Where f prime is above, f prime is positive, so f is increasing. And where f prime is below, f prime is negative, so f is decreasing. So we started on the top of the sign chart and made conclusions on the bottom. And we kind of saw, okay, this is what my graph is doing because I have little horizontal tangents because all of these were zeros. So smooth turns. So increase, smooth turn, decrease, smooth turn, increase, smooth turn. Got it. And then what was the last thing I said before the relative extrema? Does it make sense if this looks cubic as a derivative that his original would be quartic? Yeah. Because the derivative of the 4th degree, bring down the 4 and now it's a what? 3rd degree. And this isn't a positive quartic. We remember end behavior last year, right? Even powers, this is a negative quartic, true? So if it's negative, what's its derivative going to be? A negative cubic. Oh. So then if we come over here, who do we have yet again? A graph of f prime. So I'm going to draw, because it seems like his domain is all real numbers, since he's seemingly going on forever. I'm going to draw a sign chart. Question. Based on the graph that I have, am I starting by filling in, I already circled it, the top or the bottom? The top, because I have f prime. But before I go thinking about signs and weirdness like that, what are my critical numbers?
Negative 1, 5.
Negative 3. Not him? No. Remember zeros of the derivative. Negative 3, 1? Does that sound about right? Because that's 2, so 1. And then who's my other critical number? 5. If there were any vertical asymptotes or holes, those would be critical numbers as well, because those would be DNEs of my derivative. Okay, so I took the zeros of the derivative. I took the intercepts. Those are my critical numbers. Those are the zeros. Those are at the top of the pitchfork. what sign, think carefully, what sign would f prime be in the interval negative infinity to negative 3 according to the graph? Negative. Can anyone, though, explain to me why so many students would say positive?
Since it's going up, they would see as
They-
being positive.
They look at him as f and they say, he's increasing. I don't care what he's doing as far as increasing, decreasing. He's the derivative. I only want positive or negative. And what does it take for him to be negative? Be below. Why is there negative below? To be below, right? What does it take for him to be positive? To be above. So we just have to ask ourselves, okay, this side, from negative infinity to negative 3, is he above or below? Below. Sweet, he's negative. The next interval, above or below? Above. The next interval, above or below? Above. Next interval, above or below? Below. We're not looking at how f prime is increasing or decreasing. There is meaning to that. It's actually f double prime, and that's the next section. But we're not looking at that. For f, we have to just say, to figure out what f's doing, we need signs of the first derivative, so we just say above or below. Now we look at the signs and say, oh hey, what's f doing? He's not here, I don't see him. I just look at the sign and say, oh, of course, f is doing what? And then f is, and then f is, and then f is. Does that make sense? Now what can we say from that? Now first of all, since, it says somewhere in here, I don't even know where. Does it not? Oh my goodness. It doesn't. F is continuous. Sorry, that should have been stated. Total fail on the book's part. F is continuous. If F is continuous, then we can continuously, that's weird.
Yeah, it is.
Right? He like increases, he flattens, he increases some more, and then he decreases. Now guys, I'm not saying this has to be like above or below the x-axis. I'm just trying to get a shape from my arrows just to have an idea of what's going on. Question, what degree would this polynomial have? How many branches? 1, 2, 3, 4, 5. Technically this one could have gone down and back up. 1, 2, 3, 4, 1, 2, 3, 4, 5. Does it make sense a 5th degree polynomial would have a 4th degree derivative?
Yeah.
Oh, maybe that's a clue for polynomials. Anyway, question. We've already figured out the increasing and decreasing from the sign chart. Can we say that there are any relative, first of all, maximums?
Yeah.
Where? At the 5. Why? Because the derivative changes from positive to negative. And specifically, I could also come up here and shortcut it and say, hey, he's above there, the derivative. He's below there. Whenever I have a positive to negative change, that means it's a relative max. So relative max at the critical number, x equals 5. Are there any relative mins? Yeah. You can see it clearly in the sign chart because decreasing to increasing. F is changing from decreasing to increasing. F prime is changing from below negative to above positive at, what's that point? X equals negative 3. I don't know the point, I don't know the y values because I don't know who F is necessarily, but I do know kind of how he moves and how he changes, and I can figure out some important information. By the first derivative test, the derivative changes from negative to positive or positive to negative. That's the shortcut. Why is there nothing at 1? Because it doesn't change. It's above, above, or positive, positive. Okay, with those, let me see the next example and whether or not I actually want to do it right now. Yeah, let's go for it. This is one I actually didn't end up giving you for homework. I almost did, and I thought it'd be a little too complicated. But I just wanted to talk about it really quickly. We're taking a quick break from the graph, so those of you guys that are like, ugh, I hate the graphs, just hang in there. We're going to work on it a little bit more. So I want you guys take a second, read the directions. Where must F, bless you, have critical numbers? Must F have any relative extrema and justify? Question, do we have equations or do we just have graphs? We have equations or graphs? Oh, stink, we have neither. What do we have instead? We have like random points. Now, could you put all these points in a graph? I suppose. Oh wait, what is a table of? Oh. Huh. That's the table of the derivative. So, wait a minute, critical numbers, come on kiddos, forever's, right? Critical numbers, pitchfork, it's when f prime, well first of all, when f exists, it says f is differentiable, so is f continuous? Yeah. Someone nudge Corey, come on Corey. F exists, if f is differentiable, he's continuous, that's a check. But then also f prime is 0 or DNE. If f is differentiable, are there any DNEs? Remember, differentiable, the derivative has to exist. So all we're looking is f prime 0. Does it have to be 0? Well, I don't know. Wait, look at your table. How can I tell if f prime has to be 0 even though I only know certain points and I don't exactly know how they connect? If it passes from negative to positive, Brian, what theorem is that? IVT, intermediate value theorem. If it goes from a negative to a positive, it has to hit what? 0. Now, hold on, are there any more?
Yes.
Where? So how many critical numbers does it have to have? At least 2. I know the overhead's going to get even turned on yet. Just hang in there. It smells like old stuff. Critical numbers must have at least 2. Since f prime changes from positive to negative. Let's just do this. Changes signs. At least twice. And I'm going to actually tack onto the beginning, that's where I should have started. By IVT, I didn't make a full sentence, but by IVT, f must have critical numbers at least 2 different times, since f prime must equal 0 at least 2 different times, since f prime changes signs at least 2 different times. Okay, that's all of that, blah, blah, blah. Must it have any relative extrema?
Yes.
Why?
Differential.
By the first derivative test, if f prime changes signs at least twice, and if I know that f is differentiable, okay, so by the first derivative test, it must have at least how many extrema? 2. I'm not saying exactly which one, but technically it would have to have at least 1 minimum there, and at least 1 maximum there. So I could say, by the first derivative test, since f is differentiable, actually I should say, I suppose, since f is continuous. And f prime changes signs at least twice. There must be at least 2 relative extrema. Could be more specific, but they didn't actually necessarily ask me to be more specific, so I'll just stop. Or maybe it's my screen. Why would it be doing that? I think it's the screen. Well, that's been tucked up way too long. Okay, let me open the door. But do you guys see how sign changes mean stuff now? Do I know exactly? Who threw away a water bottle? Who had gum? That's two pieces of gum. Okay. One more. Oh no! What? They threw that didn't work. Emotion problems? In the homework? How could they? The shock, the horror. What are they asking? A, find the velocity function. Wait a minute, who's the velocity function? I'm helping you in a homework problem. The derivative, right? So when it says find velocity, it just says find s prime. Okay, B.
Identify the sign of the velocity.
When the particle is moving in the positive direction. Guess what? Positive direction means the position is increasing. Oh, so all it cares about is when S is increasing? Hey, look, huge paragraph and condensing it down to a couple words, right? You can use that too in your homework for directions. Letter C, if it says position moving in the negative direction, what does that mean for position? Decreasing. Oh, we're going to do a increasing, decreasing sign chart? Mm-hmm. And then letter D, identify the times at which the particle changes direction. That's the relative extrema, guys. Because isn't changes direction the same thing as changing from increasing to decreasing? Isn't it going to happen at relative mins and maxes? Oh my goodness, sign chart applied. So then for letter A, all we have to do for this one, whew, at least the derivative is easy, right? Velocity equals derivative of position, which equals, oh, did you guys get the function down? 3t squared minus 40t plus 128. Ugh. I don't want to factor that. If we had to find our zeros, and it was big old nasty numbers that don't factor very nicely, at least I don't think they do, what do you think we could do? Graph it and find the zeros. Graph it and find the zeros. Why are we finding the zeros? Because we got to make a sign chart. So we're going to set all of these equal to 0. First of all, that is my velocity. Dun, 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 dun. I'm setting equal to 0, so we need to do a sign chart. So my critical numbers, otherwise known as my stopping points. Stopping points? Oh, velocity is 0. Hey, that's a thing. Some of you guys are graphing this for me, right? Thanks,
Yeah.
Brandon, Jason, you're on it. A few others might be backing them up. Just see if you agree, and if so, give me answers. There should be 2 of them. Stopping points, right? I'm trying to figure out where this stops. And then what am I going to do with those stopping points? Well, letter B, I'm getting all set up. I'm going to put it in the sign chart. And I'm going to say, hey, what are the signs of my velocity? What does it tell me about my position? Did you find one yet?
5 1/3.
5 1/3?
Mine B.
Is there only one?
No, there's 2, but that's the first one.
Okay, thank you.
Thank you.
And 8?
Yeah.
Oh, I guess we could have if we kept on looking and figured out the factors, but let's not. And say we didn't. My kiddos that have the graph before you, they have a graph of the derivative.
Yes.
I have my 5 1/3, he's here-ish, right?
Yes.
I have my 8 and he's here-ish.
Yes.
Is my parabola facing up or facing down?
Up.
Why am I saying this? If you're allowed to use your calculator, Christian, it was you that said like plugging in and testing could take a while, right?
Yeah.
Okay, if we have the calculator, and this is the derivative, what can I say about the sign of the derivative before without plugging anything in? Is he above or below?
But
He's above. Sweet. That's how to use your graph the right way, right? Now, here, where is he? Below. Ha! And then where is he? I didn't have to test anything. What? Sweet. So therefore, I have my increasing, I have my decreasing, I have my increasing. Kiddos, I have the answers for B and C. Right? Because for B, I can say, when is it moving in a positive direction? I can say, oh, sweet, whenever the position is increasing, which is going to be for T within, oh, remember, T is my X in motion, right? When T is within negative, does it give me some sort of restriction on this?
0.
Oh, I was supposed to start at 0. This is one of those, I should have cut it off. Because it's not going to negative infinity. Time is starting at 0. So we're going to say it's increasing from 0 to 5 1/3 or 5.333. Remember, always 3 decimal places. And it's also increasing from 8 to infinity. Just says greater than.
And.
Or, and, technically in math is where they overlap.
Or.
If I have 2 separate answers, I need to put an or. If you really want to, just put a comma and just be like, there you go. They probably won't mark you off. And then T is within 5 1/3, and 8 is when position is decreasing. And if it says identify the times at which the particle changes direction, well, he does a turnaround at 5 1/3, and he does a turnaround at 8, right? He's moving this way, and then he backs up, and then he goes that way some more. So my turning points are my critical numbers. T equals 5 1/3, and 8 seconds? I don't know. They didn't tell me, did they? Nope. Done. Not too bad, right? And I gave you what the directions were to summarize and then do one sign chart. Use your calculator, cheat a little bit, and you're done. But you have to know how to cheat a little bit or else it's going to not be good. Cool? Okay. I want you guys to go ahead and get out that little paper I gave you, but stay in your notes because we're going to write some clues about AP numbers. Okay, AP number 2. Let me show you what AP number 2 is first. And then let me go ahead, after I show you, bless you, what AP number 2 is, then let me talk it through. Uh-oh, this isn't good.
I'll fix it.
It's okay, we'll figure it out. It was hidden in Mr. Park's cupboard. Mine kind of got borrowed by another teacher,
You need another
and
screw.
I haven't gotten it back yet. Right? See, I told you. She didn't believe me. Okay.
What are fingers of steel?
Where's my psh, psh, psh? Does anybody see my psh, psh?
Did you do it?
Okay.
Oh.
Ready? Over to the side of the room. Do you guys see those little like Ziploc bags behind my pie sign with my name on it? That's supposedly a bathroom pass, but everyone got freaked out about the germs last year, so whatever. Okay, so. There we go. Okay. Over there in those little Ziploc bags, there are piles of cards. There should be, guys, how many spaces are there on your sheet? 16, and there are 4 columns. The 4 columns have meanings, even the first one with 1, 2, 3, 4, 5, 6, okay? So 16 times 4.
64.
64, right? Okay. There are 64 cards. Here are the different categories of cards.
Fingers of steel.
First of all, let's do that. Second of all, let's do
Oh my god, it smells so bad.
something about it.
Tape it.
Yeah.
Or have someone hold it. Oh, I smell it.
Have someone hold it. If you want to move momentarily, you can, my little one.
You got two. I don't want to, but
Okay, that's
I'm gonna
problem
be able
solving.
to.
Okay,
That
so
was a joke.
here are the categories. Ready? You guys looking at the top of your table?
Yes.
Is there a category for function graph?
Yeah.
Guess what? Draw that picture real quick on number 16. Underneath the function graph. And those little columns are going to draw the graph that goes with the number. Okay, so the number, that entire row, the 16th row is supposed to be all the cards that match with this function graph. Does that make
Okay, can you
sense?
draw this in
Yeah, sketch it. Sketch it in a little box because there's room in there, right?
16?
In 16. Right next to the number 16 in the function graph column. We're learning what a table is. Okay, so function graph, right? What's the next column of what we're going to need to match? Function description. Uh-oh, function description. What are those? Ready? I'm giving you only 4, even though there would be 16 options available. There are 16 cards of every single column, right? Oh, it's not working. How about now?
Yeah, that's right.
Okay. I know.
You have to match it.
You have to match it. It's a card match. Now, technically, there are 16 different function descriptions. Okay, there are 16 different function descriptions. I just picked 4 of them. I promise that the match is in here. If we work together, we can actually fill in something.
It's not F.
Why is it not F? 4 critical points. This has only 2. Okay, not that one. A, there is no A.
H.
H.
Wait, why?
You put H.
H.
Because it can't be 1 critical point, right? It has 2. It has a relative min and a relative max. Angle of inclination, that would be like a line. It'd be an angle. That's not a line. Interesting. Okay.
Do I write that whole
Fill in H. No, just fill in H. Now hold on. Do you see little tick marks measured at -2 and +2 for the relative minority mass? Why not? Because that would make it too easy. You would just match all the numbers and not think about anything. But is there something negative and something positive? Yes. Does that make sense? Now there are a couple descriptions that might work for more than one graph. If you read it and they're literally the same wording, I will take either one for certain ones. Okay? So if they're the exact same wording, it could go 2 different places. Now we have this, right? What's the next column? Derivative graph. Okay, so then what if I start putting my different possible derivative graphs? Now remember, there are 16 different available. I just picked 4 and the right answer is in here.
It's not 4. It's
Why is it Roman numeral 5? That one's a cubic. His derivative would be a quadratic. But couldn't you also think of what we're doing in class? Wait. Couldn't you also think of what we're doing in class in the sense that, here, I'll do the smelly apple one in case it might help. Isn't the function increasing? So the derivative is above, and then it's decreasing with a 0. So then it's negative, and then it's 0 again, and then it's positive.
Oh, really?
Okay, so we have, we need one more, right? Derivative description, what's that? Words to describe the derivative. Remember, there would be 16, I'm giving you just 4.
Okay, that's my childhood.
I never would have. Oh, I was supposed to.
I'm moving.
Yeah, but
So now we're looking at this one, right?
Oh, which
Why not this one?
Hey, that's too many words.
Oh, this one only has 2 zeros, right? Okay, it can't be E.
I thought it was 9.
Wait, what would this one look like? Always -2? Wouldn't that be a constant?
No, that's a K. No, G goes up.
Miss D, is that a Q or a G?
Oh, it is a G.
A G, because the tail goes that way.
No.
Okay, so,
This is not a G. Okay, maybe
Wait, okay, but G or Q?
G.
why is it not M?
Not because
It would need to be above everywhere here. Oh. And it would need to be below every, no, right? It's below, right? It's below -2 to 2, and it's above everywhere else. Did we get a match?
Yeah.
Okay, let's pause for a second. And let's go back to our notes. If I can hit the right button. Thank you.
But that would be
It's not on fire, the overhead might be. Okay, so, just kidding, the dust in the overhead is on fire. Okay, so, what were some skills we just used to make those matches? Now remember, I only gave you 4, I kept it limited, and I only had so much space on my overhead screen. But, either way, we were able to make a match. You have 1 full row filled in, right? Okay, hold on. How did you guys think about critical points? Now wait, there were 2 different types of graphs, right? On an F graph, on a function graph, how do you think about critical points? Because remember, you looked at the function graph, which was the cubic, and you were like, hey, he has 2. How did you figure out he had 2 critical points? 1 horizontal tangent there, and 1 horizontal tangent there. So for a function, critical points, we're looking for, basically, relative extrema, right? Or other horizontal tangents sharp points or VTLs, vertical tangent lines. Okay? How are we going to see critical points on a function? We're going to have to look at how many mins or maxes he has, which could be smooth or could be sharp, and how many vertical tangents he has. Those are my critical points. When the derivative equals, well, hold on. So if I'm looking at the derivative, how do I think about critical points of the original? Are they going to be zeros, aka x-intercepts, or DMEs, like maybe vertical asymptotes or holes, or jumps, I suppose. I guess you could say or jumps. So it could be a jump discontinuity. So in the function, we're looking for the turning places, the relative extrema, other horizontal tangents if they have any sharp points, vertical tangent lines. On the derivative, the critical points match up with the zeros or the discontinuities. Okay? Those are the clues for critical points. What was something else we talked about for sake of time and just going? If a graph talks about absolute versus relative extrema in the description, question, who is he? Absolute and relative, right? So if you're like counting, this one would be absolute and relative max. This one would just be in relative min, because it goes lower, right? And this one would just be a relative max. Quick reminder, right, of the difference between absolute and relative. So you saw that they were saying like, hey, it has so many of this, that, and the other. They might say it has 2 relative extrema or something, and you have to know what that means. Pause. There's one more quick clue. Points of inflection. Points of inflection. Remember, a point of inflection is where concavity changes, where concavity changes, or where concavity changes. Just, it might show up in the description. Kiddos, we might do a couple more clues on this tomorrow. It's not due until next Tuesday. But if you have your group already figured out, 1 deck of cards per group, grab it on your way out. 1 representative. Until you figure out your group, you can pick them up tomorrow as well. But only 1 per group of 3 or 4.
Good idea.
Bye, guys.
My daughter was not giving them Noah. It's probably the least likely.
You can grab them tomorrow, but you better have your group figured out and only be picking up 1. I don't have enough for everybody.
Where's the card?
They're right there behind the wooden
Aaron, you ready for a Quidditch game? Do that. Yeah, boy. No, boy. No, greatest point. I thought we were going to share cards.